Okay, welcome back to our 2023 question paper, past paper discussion. So, in my previous videos, I have discussed the questions up to the 30th question. So, now I'm going to continue from 31st. So, match the given entity attributes labeled from A to D to the corresponding descriptions labeled from 1 to 4. Okay, so this is regarding to ER diagram, attributes. So look at the description. Number one, an attribute that cannot be broken down into smaller components. So it's called simple attribute. That attribute cannot decompose. So number two, an attribute that can be broken down into component parts. Yes, the composite attribute. Composite attribute means a collection of attributes. The attribute whose value can be calculated from related attribute values, the derived attributes. The derived attributes always depends on some other attribute or attributes. Then number four, an attribute that may take more than one value. Multi-value attribute. So as example, in the customer table, telephone number. So sometimes some customers has multiple telephone numbers, ne? So in that case, the telephone number attribute should be a multi-value attribute because some customers has multiple telephone numbers. Okay, so A2, B1, C4, A2, B1, C4, D3, number 2. Yeah. The number 32, consider the following employee relation. There's a table with 3 columns, employee ID, employee name, and salary. What would be the output of the following SQL query when it's applied to employee relation? So select count all from employee where salary greater than any. Okay. Here any means the lowest value in the salary column. So here lowest value is 55,000. So where salary greater than any. So greater than the lowest value. So how many values are greater than the lowest value? 1, 2, 3, 4. Ne? Greater than 55,000 is 4. So it says select count. Select a count. Count the salaries which are greater than the lowest value 55,000. So number 4. Ne? There are 4 other rows. So number 4 is the correct answer. Okay, so next question, number 33. Consider the given SQL statements to create 2 tables named lending and student. Lending and student. So which of the following statements are correct? Statement A. Student ID is a foreign key in the lending table. So create table lending. Book number is the column name. Then the data type is Vacha. Length is 10, not null. It's enter data is a must. And book name Vacha 20 not null. Author Vacha not null. Description Vacha not null. Issue date. Student ID Cha not null. Primary key is the book number. So statement is a student ID is a foreign key in the lending tables. Okay. So this is the lending table. And the student table. Student ID. Cha 5 not null, name Vacha 25 not null, birthday date not null, address Vacha not null, province Cha, primary key student ID. Okay, so student ID originally exists in the student table because the student ID is a property of the student table. It belongs to the student table, and lending table is using the student ID. Yes, it should be there here. Student ID as the foreign key. Yes. So statement B, it is compulsory to input data to the data type fields in both tables. Okay, so data type is using in issued date. Here is the data type for the column name issued date. But there's nothing mentioned about not null. The property or the attribute not null is not mentioned in the lending table regarding to the data type. There's no not null. That means null values are accepted. Empty values are accepted, not compulsory. And in the other table, date type is here for the birthday. Okay, it says not null. That means it's compulsory. Yes. So V statement says compulsory input data to the data type fields in both tables. No. In the lending table, issued date is not compulsory. So B is incorrect. In C, student ID can contain only 5 English letters. Can contain only 5 English letters. So student ID. So student ID is in the student table. It's char 5. Yes. Can contain only 5 English letters. So char 5 means there should be 5 letters, five symbols or letters or numbers or whatever. Only 5, not less than 5 or not greater than 5. There should be 5. That's the specialty of char data type. But here it says 5 English letters. So there's nothing mentioned about English letters. So char 5 means any text, any characters, any 5 characters. It could be numbers, symbols, characters, whatsoever. So the problem with English letters, so it can't be. So C is incorrect. So the correct answer is 1A only for the 33rd question. Right, number 34. When the employee entity of the following diagram is represented in a database, which of the following should not be included? Okay. Yes. Uh, when the employee entity, so when these ER diagrams, employee entity represents in a database, which of the following should not be included? So what are the answers? Date of birth, designation, employee name, employee number, qualifications. All are attributes. So what is the invalid kind of attribute? What is not suitable for a real database? Which attribute is not suitable for a real database? So date of birth, employee number, employee name, designation, all are normal attributes, simple attributes. Age is a derived attributes. So simple attributes, derived attributes are both are acceptable in a real database. The qualifications is a multi-value attribute. So multi-value attributes makes troubles for a real database. So real databases should get rid of multi-value attributes. So remember the first normal form. In very first normal form, there's a rule called no multi-value attributes or multi-value columns. So the real databases get rid of these kind of situations, even in first normal form. So they real databases starting without these kind of multi-value attribute because it makes lots of troubles. So qualifications should be the answer. Then 35, which of the listed relations will be obtained in the following ER diagram is correctly mapped into the relational model? Which of the listed relations will be obtained? All right. So there's a one-to-many relationship. One-to-many. So at the left side, lecturer entity and the other side, course entity. Lecturer entity got 4 attributes and the course entity got two attributes, and the relationship also got a one attribute called hours. Um, so statement A, lecturer, NIC, lecture name, DOB. So lecturer got NIC, lecture name, DOB, and address. Yes, it represents all the attributes in the entity. In statement B, lecturer, NIC, lecturer, and DOB, address, course ID. Okay, so statement A is all right. So lecturer got all the attributes, all the lecturer's attributes. And B statement, uh, lecturer name, DOB address, course ID. So there's no requirement of represent the course ID at the lecturer side because this is a one-to-many relationship. No point of indicating the course ID at the lecturer's table. But the lecturer NIC should represent in the course table because the course table should represent what is the course name, what is the course ID, and who is the conducting lecturer. So it's there in the course D. And hours. There's a attribute. If there's an attribute for the relationship in one-to-many in one-to-many relationship, right? In a one-to-many relationship, if you can see an attribute for the relationship, that attribute should added to the many side. Attribute should added to the many side, the course side. So the course should contain hours as well, right? Hours as well. So, but if this is a many-to-many relationship, and if there's a many-to-many relationship, and if there's an attribute or attributes for the relationship as well, then that means there's a hidden table in that diamond, right? So there's another third table which has the common attribute from the left side entity and the right side entity. So there'll be three tables when you convert in these ER diagram to the real database. But in this case, it's not a many-to-many relationship, it's a one-to-many relationship. So therefore, that the relationship attribute should add to the many side. So yes. So teachers, there can't be any table with the relationship, and it's not possible. And B, lecturer, yes, course ID is not a requirement for the lecturer side. AD, number 3 is the answer. And number 36, which of the following gives the correct matching between ER diagram components and the relational model? Okay, so entity, field. No, entity means table. Entity is table, entity table, entity table. Attribute is a field. Yes, field, a column. Yes, that is correct. Attribute is field. Attribute could be a primary key as well, but generally attribute is a field. Attribute is table. No, definitely no. Then unique attribute should be a primary key. Unique attribute table, no. Unique attribute primary key could be. So multi-value attribute could be a table because multi-value attribute means multiple attributes, multiple columns. Multiple columns makes a table. Okay, so multi-value attribute, a table that, combination is correct. Here, multi-value attribute table, that combination also correct. So the attribute could be a primary key and attribute could be a field. Now we have 2 and 4 in second answer. Attribute could be a field, attribute could be a primary key, and unique attribute primary key, unique attribute primary key. So here primary key has been repeated in the fourth question. So the most correct one we can select as the number 2. So normally attribute is a field and the unique attribute we can call as a primary key. Okay, then number 37. Which of the following statement are correct? So there are some relational schemas are there. Advisor, add ID, add name, add gender, add NIC, add phone. Farmer, farmer ID, farmer name, farmer address, farmer phone, and task relation, task ID, task name, farmer ID, start date, end date. Advisors, advisors and advisor, two different relations. Add ID, task ID. So both are primary keys. That means there's a composite primary key. Start date, end date. So one farmer can have many tasks. So farmer, in the farmer relation, yes, farmer information and task relation, task ID is the primary key, and there's a farmer ID as well. So one farmer, that farmer IDs could be repeated here because it doesn't seem unique. Under different task IDs, unique task IDs, one farmer IDs could be repeated. Yes, it's possible. One farmer can have many tasks. One advisor can advise many tasks. So advisor and advisors. So in advisors relation, add ID. That means advisors primary key. It works as a foreign key here. Add ID and task ID. Start date, end date. So one advisor can advise many tasks. Yes. The advisor ID and one advisor ID could repeat with different task IDs. One advisor ID could repeat with different task IDs because the combination should be unique. Yes. So one advisor can advise many tasks. Yes. One advisor ID could repeat with multiple task IDs. The only requirement is the combination should be unique since this is a composite primary key. For one task, a farmer can have many advisors. For one task, a farmer can have many advisors. So what task has the farmer ID? Farmer ID, yes, farmer ID could repeat with different task IDs. So farmer can have different tasks, right? For one task, farmer can have many advisors. Yes, the task ID and advisor ID in the advisors. One task could repeat with multiple IDs, advisor IDs. That is also possible. So one task could repeat with multiple IDs. Again, the combination should be unique. So that means one task could have multiple advisors. So that means a farmer can deal with multiple tasks, and farmers, one task could have multiple advisors. So that is also correct. So number 5. Then number 38, which of the following statements are correct with respect to the given relations? A, all relations are in third normal form. Okay, so all these relations are in third normal form. So what are the conditions in third normal form? Number 1 is should be in second. There are 2 rules. The first rule is should be in second normal form. Second rule is no transitive dependency. Number 1 is should be in second normal form. Number 2 rule is no transitive dependency. Right. So advisor table got a primary key, add name, add gender, add NIC, add phone. So it seems third normal form. And farmer table, farmer ID, farmer name, farmer address, farmer phone. It got one primary key, so it's in second normal form, in a single column primary key. and there's no transitive functional dependencies. That means the dependencies between non-key columns. Dependencies between non-key columns. I can't see any dependency here. In task, there's a single column primary key. So task name, farmer ID, start date, end date. Yes, this seems also in the third normal form. And advisors, table, add ID, task ID. So both columns are the primary key. It's not a single column primary key. It's a composite primary key. Start date, end date. So advisor ID and the task ID. Start date, end date. So start date is not partially depend on the primary key, and end date also not partially depend on the primary key. And so it's in second normal form. And the non-key columns are start date and end date. So these two doesn't have any uh, transitive functional dependency. So it seems it's in the third normal form as well. Yes, A is correct. Then B, the start date attribute in task relation is a derived attribute. Task relation, start date. So task ID, task name, farm ID, start date, end date. Now, start date is not derived from any other attribute. Not derived. So it's a simple attribute. So derived attribute means if its value depends on another attribute, or if its value generated according to another attribute's value, then it's a derived attribute. But here we can't see any related attribute to the start date. So B is incorrect. Add NIC is a candidate key in the advisor relation. Advisor relation, add ID. Advisor, add ID is a candidate key in the advisor relation. So it's underlined. So that means it's a key relation, key attribute. So candidate attribute means the attributes which are qualified to become the primary key. So at ID seems a qualified one to become a primary key compared to other attributes. So C is correct. So number 3, AC. Then number 39. What would be the output of the following Python code if A equal 10, B equals 4, and C equal 7? Okay. So A equal 10. Modulus B 4 plus C 7. Integer division or floor division. A is 10 minus B is 4. Right. So what we have to do is find the execution order of these operators. Execution order. So we learn this under the Python operator precedence. So highest priority always goes for the brackets. So 10 minus 4 is 6. So 7 integer division plus 4 modulus 10. So now we got modulus plus and integer division. So which got the highest priority? The modulus and the floor division both are both priority in the same level, and also it's higher than the plus and minus. So from these two, modulus and integer division, the first execution goes for the most left one. First execution goes for the most left one. So most left one is modulus. So 10 divided by 4 is 8, remaining 2. So 2 plus 7, integer division 6. From plus and integer division, the highest priority goes for integer division. So 7 divided by 6 is 1. So 2 plus 1. 2 plus 1 is 3. So number 1 should be the answer.